Do you know what I find is the biggest pain when you get sick? It's not the pain in your teeth, in your ear, or wherever you have your medical complications. The biggest pain is the pain of waiting. You call the doctor's office, they put you on hold for 10 minutes. You want an appointment for this afternoon? You get one for next week. You finally arrive to your appointment, which is at 2 o'clock. You sit in the waiting room until it is 4 o'clock. Medical care, just like many other services, is all about waiting, waiting, and waiting. But why do customers have to wait? Why can't the care not be instantaneous? In this module, we want to understand the concept of responsiveness. How can we be quick in responding to our customers? Waiting, of course, is just another form of a mismatch between supply and demand. When we are waiting, we as patients in the waiting room are inventory. And it's simply no fun being inventory when your ear is infected or your teeth hurt. So understanding the match between supply and demand, once again, is going to be a crucial issue of solving this waiting time problem. Now let's represent the physician's office in form of a process flow diagram. This is a really simple process flow diagram. We have a waiting room and we have the doc doing the work as the only resource in the system. Now say for sake of arguments that patients arrive at a rate of every 5 minutes. So over the course of an hour we have 12 patients come in per hour. Moreover, let's assume the doctor spends on average 10 minutes to serve a patient. That means we have a capacity of 6 patients per hour. Now first let's ask ourselves, what's the implied utilization in the system? Now remember from our discussion of process analysis that the implied utilization looks at the ratio between demand and capacity, which in this case is simply 12 divided by 6 equals to 200%. How long will patients have to wait in this practice? To see how long patients have to wait, let's just do the following thought experiment. Let's just look at the day in the life of the doctor and start early morning, say at 8 a.m. when the practice opens. The first patient who comes into the practice probably will not have to wait and get served immediately. However, as the day unfolds, things get worse because we have 12 patients per hour come into the practice and 6 patients per hour being served. What happens is we have an accumulation of waiting patients. Inventory. How quickly does this accumulation occur? Well, we have 12 patients come in, we have 6 patients get served, so every hour we're accumulating 6 patients in the waiting room. For example, at 10 a.m. I have 12 patients in the waiting room. At noon, I've been operating for 4 hours at a capacity shortfall of 6, and I will have 24 patients in the waiting room. So the person who comes in here at noon has 24 patients in front of him or her. Every one of them will take 10 minutes, and so the waiting time will be a total of 240 minutes. Quite a long time. A pretty scary example. Let's look at another example. Here is another doctor's office. Same thing, same process flow diagram, and a patient arriving every 5 minutes. So 12 patients arriving per hour. It takes this doctor here, however, only 4 minutes to serve the patient. So our capacity is much higher, and the doctor can have a capacity of 15 patients per hour. We can compute the utilization now as the ratio between the flow rate to capacity, and the flow rate, remember, is the minimum of demand and capacity, and so the flow rate is 12, the capacity is 15, and we have a utilization of 80%. Surely in this practice, no patient will ever have to wait. Or maybe they have to? Imagine this doctor would be called Dr. Toyota. Now, Dr. Toyota runs a very proper practice. His patients arrive exactly every 5 minutes. So one at 7 o'clock, one at 7:05, 7:10, and so on. Moreover, Dr. Toyota knows what he is doing. He has standardized his work to a 4-minute processing time. The patient is still half undressed. After 4 minutes, Dr. Toyota says, "Sorry, gotta go, business is business." Well, this is arguably a very unrealistic example. I make things realistic in just a moment, but I want you to see a very important point. It is indeed possible to run a business with a utilization of 80% and have no waiting at all. Look how the patients arrive and when they leave. 4 minutes of work, a minute of idle time for Dr. Toyota, 4 minutes of work, a minute of idle time, and none of these patients ever will have to wait. Now, arguably, my story of Dr. Toyota was very unrealistic. What type of doctor would serve exactly every patient in 4 minutes? What type of patients would arrive and get sick, exactly one patient every 5 minutes? Now, what do we mean with unrealistic? More realistically, we would say that the arrival times when these patients come to the practice are somewhat random. I will formalize the idea of randomness in just a moment, but consider the example here of 12 patients spread out over 60 minutes in less of an assembly line fashion. Moreover, look at the processing times for these 12 patients. Some of them are longer, others are shorter. That's, I think, what most of us would mean with a more realistic set of processing times and arrival times. Now look what happens in this more realistic setting. Notice first of all that our utilization has still remained at 80%. Because, after all, the average time between two customers' arrivals is one customer every 5 minutes, 12 customers over the hour, and the average processing time has remained at 4 minutes. Yet, despite this utilization of 80%, you see that the picture changes dramatically. I noticed that some patients, if you consider the patient number 5 and 6 here, these poor folks have to wait 3 or 4 times as long as their actual service times. Instead of looking at the patient wait times and service times, I can also look at the inventory. And you see that at a certain moment in times, I might have 3, if not 4, patients in the practice. All of that at a utilization of 80%. When a doctor has 6 patients per hour arriving to her waiting room, and the doctor can only see 3 patients per hour, the times the patients will have to wait get longer and longer. This is clearly a result of insufficient capacity. Whenever you encounter waiting time problems, the first thing that you should think about is what can I do to increase the capacity of the resource. What we've done in our earlier discussion in the module on productivity analysis is a really good toolbox to free up some capacity. We also talked about flexibility and making sure that we have the capacity available at the right time. However, we noticed in this session that oftentimes waiting is not just driven by insufficient capacity, but it's driven by variability. We notice that variability doesn't average itself out. Think about it. Would you jump into the lake head first if the lake is deep 10 feet on average? Averages really only tell half of the story. For this reason in this module, we'll focus a lot on variability, which is an important way to describe both the demand process and the supply process beyond the simple averages.